Hello there. Welcome to the Mechanics of Solids video lectures. In this video lectures, we are trying to learn what are the different types of the stresses. In continuation of the last video lectures, we have discussed about the types of loads and the stress. We know that the stress is nothing but the internal resistance force is going to be developing for the unit area of the member when it is going to be subjected to the external loads, right? So that's we have taken that in the last video lectures. So now in continuation of that, we are going to be tracking with respect to the direction of the applying load or with respect to the line of action. On these two bases, we are going to be classifying the developed stresses into the two special categories. The first one is going to be the normal stress and second one is going to be a tangential stress. And it is with respect to the applying the load. At the same time, the respect to different shapes of the objects also, we are going to be classifying the normal stresses into the two special categories. The first one is going to be your tensile stresses or compressive stresses when we are applying for a respective bar members. But when we are applying for like a cylindrical objects which having a hole, suppose we are going to be taking a container which is using to carry the petrol, diesel through the tankers. So those are going to be, another example is going to be the boilers. So in this case, what will happen? The stresses which are going to be developing inside that boiler is going to be classifying into two more categories. That's going to be longitudinal stress as well as the hoop stresses or circumferential stresses we are going to be calling. So with respect to the direction of the applied load, with respect to the line of action, I am going to be classifying the normal stresses into two categories. First one is going to be your tensile stress, right? As we know that the tensile stress is going to be developing because of the tensile loads, right? That means here, so for the tensile forces we are going to be say that's going to be sigma T is going to be the indicated letter. That's I'm going to be writing the load by area. I'm going to be saying that load is nothing but that's going to be applying the load. A is going to be your cross-sectional area. This cross-sectional area, how it is going to be existed. Now I'm going to be draw the pictorial view to understand this part. Suppose I am going to be taking one of the member circular rod, or you can take the rectangle bar also. So that I am going to be taking for the convenience the circular in this member. So there we can see it is going to be subjected to the pull forces, right? This is going to be the P. So then what will happen in this case? So this is going to be your length of the member that I am going to be say L, and the diameter of this member is going to be the D. There we can see the load is going to be acting along the neutral axis of that member, and that means the load is, this is going to be saying that external force. So then in this case what will happen, I am going to be mentioned that's going to be the externally applied load that is equal to the internal resistance force magnitude. And this cross-sectional area we are going to be seeing, we can see here the cross-sectional area, we should not take it the L into D. This is the surface which we are taking, which is parallel to the applied load. But this cross section we have to take must be perpendicular to the applied load. Suppose I am going to be cutting over here. Can you see this? Whatever the cross section I have taken here, this is going to be the perpendicular to your applied load. For simplification, I am going to be taking over here. So then can you see here that's the object is going to be, the load is going to be acting here. So this is going to be the P and the P dash. If I am going to be taking a section plane here. So can you see this cross section? This means the applied force is going to be normally to the cutting plane of that member, that is onto the surface. Then we can say this is going to be the area. That is this area we must be take. That area must be normally to the applied load. So further simplification of this one, the P is equal to area. So what is the area of this circular? That's going to be pi by 4 d square I am going to be taking. By using this equation, I can calculate the tensile stress. Now, in continuation of this one, the normal stress 1 is going to be classified according to the direction of the applied load. There we can see the load is going to be applied in the opposite direction. They exist in the collinear. Now we can see the load which is going to be acting in the opposite direction of the member. Now we can see here in the normal stress, second one is going to be your compressive stresses. In the last cases we have seen the tensile stress which trying to elongate the member along the direction of the length of the member. There in this case what will happen, the force is going to be trying to push the object towards the central positions. There we can see the P force is going to be acting on this circular bar. So there we can see these two forces are going to be trying to compress in this direction. Due to this reason, the member is going to be trying to change its dimension in this direction. So changing the directions means here the length is going to be reduces and the diameter of this member is going to be increases. So that we can see in this direction. That means in the side view also we can see. In this case, what will happen? Already we told the normal stresses sometimes we are going to call direct stresses. In the normal stress, what happened? The area always must be normally to the applied force. There we can see this is going to be the force line of action of your member and the direction also we have shown. But the cross section area that we know, the compressive stress is equal to compressive load by, we are going to be taking the unit cross sectional area. This area must be always normally to the applied load. So in this case the same area I am going to be taking because this area is going to be suffering the load. So this equation I am going to be writing here is the compressive load pi by 4 and d square I am going to be considering. On this basis I can calculate the compressive stresses. These tensile stress and compressive stresses we are going to be calling as a direct stresses. Now we can see when these are going to be members are subjected to the bar members. But when we are going to be taking the boilers or maybe the containers for the carrying of the water or liquid like diesel or the petrol. So those are going to be the containers we do have. That means the cylindrical shells we do have. So those how they are going to be subjecting this kind of stresses we will see. So here another classification of your normal stress is going to be longitudinal stress. The most of the times we are applying for the thin or thick shells we are going to be taking. So there we can see here that I have taken the boiler, which is in the shape of is going to be in the cylindrical shape. At the ends they are going to be closed over here. Then what will happen in this case, the most of the time the boilers we are using for the generation of the steam. When the steam is going to be generating, the pressures are going to be acting on the walls of the boiler. So there we can see here. So when we are going to be closing these ends, then what happened? The pressures are going to be acting at the ends of the wall. So we are assuming that the load is going to be acting in this direction. So then these are going to be the pressures are going to be acting inside the member. So then what will happen in this case, when these pressures are trying to push in this direction, the failure is going to be cutting over here. So there we can see. So in this case what will happen? The internal stresses are going to be developing in the opposite direction. Can you see here? This internal pressure is trying to push the objects in towards the either right side or left side of the objects. But internal member, that means internal stresses are going to be, internal forces are going to be developing opposite to the applied forces. So in this case the loads are going to be coming along the members. That means the longitudinal stresses means along the axis of the member, that stresses are going to be developing inside the material. So that we are going to be considering here, that is the longitudinal stress. The second one we are going to be calling as the hoop stresses. So what is the hoop stresses? Same. This terminology also we are going to be calling circumference of the circumferential stresses. There we can see the load is going to be, that means the pressure not only at the ends of the member, at the same time the pressure is going to be acting normally to the circumferential of the member. So there we can see the load is going to be acting in this direction also. That means the pressure is going to be acting in this direction. So in this directions what will happen? The member is going to be trying to move in this direction. So that I am going to be taking over here. So when I am going to be considering the circumferential or hoop stresses, and the pressure is going to be acting radially on these members. Circumferentially it is going to be acting. So then in this case the stresses are going to be developing, which is normally to the axis of this member. So these stresses we are going to be calling longitudinal stresses, which is acting along the axis of the member, and the hoop stresses which are acting when I am going to be cutting over here. So that means when I am going to be cut this member in this direction, this half portion is going to be subjecting this kind of the stresses, and both will comes to the normal stresses. Now we will see what is the tangential stresses. Now we will see here the tangential stress or shear stress. With respect to the direction of the applied load or the line of action of the applied load, we are going to be classified. One is going to be normal as well as the tangential. In this tangential stresses, what will happen? Can you see here? I have taken a member over here, A and B is the bar. Then what happened here? The load is going to be acting in this direction from here, and the P is going to be acting. There we can see the applied forces in the above and the below of the member AB. So they are not passing in the same direction. They are passing at a distance over here. So in this case what will happen, the line of action is not matching. And the direction, one is acting in the downward direction, one is acting in the above direction, that means towards the upward direction. So then what will happen, I am going to draw the equilibrium diagram so that I can identify how the stresses are going to become. So for this one I have taken a member over here like this. So that means the left portion, and at the same time the right portion I have taken. In the right portions, the force P is going to be acting in this direction, but when we are going to be separated into the elements, then the reaction forces is going to be generating, that is the P dash. So there we can see in the left portion the P is going to be applying in the above direction, that means upward direction, but your reaction forces are coming in the downward direction. There we can see the P dash and the P dash, finally they are going to be nullified when we are going to be joining these two materials. Then we can say that member is in the equilibrium condition. That's the mechanism behind how the equilibrium condition is going to be achieving even after the elongation. So there we can see the line of action of the applied forces, they are not passing in the same line, they are passing at a certain distance, that tangentially we can. So then what will happen in this case, the shear forces are going to be generating. That shear forces we are going to be say that tau is equal to the shear force P S by unit cross sectional area we are going to be calling. So then we can say this is going to be AS, the shear area. By using this equation we can identify the tangential or shear stress. I hope you are able to understand what is the different type of the stresses. On the basis of the load direction as well as the line of action, we have classified two categories. One is the normal stresses, second one is the tangential stress. In the normal stress we have seen that there is a tensile stresses are developing and compressive stresses also going to be developing. That is going to be in the member we have considered. When we are going to be taking like a cylindrical objects like thick or thin shells, if we are going to be taking, there is a longitudinal stress and circumferential stress we have seen. And further we have seen the tangential stresses. In the normal stresses what will happen, in this case the line of action and the direction, they are going to be passing like a collinear. But when the tangential stresses, that line of action of the applied force, they are not going to be matching. They are going to be moving in a different direction. Suppose if I am going to be taking one object which I am going to be fixing here, when I am applying the force in this direction. So then what happened, this member is going to be trying to distort in this direction. Can you see the shape of the object is going to be changing? Okay, this is we are going to be calling the tangential force and the tangential stresses. So still if you feel any difficulty, please put in the comment section so that I can reach you out. So I hope you are able to understand this concept. Thank you.